Stephen from TRAXyL, all the way on the East Coast in Virginia.
Hi, thanks a lot, Jim. Thanks a lot, Anne and Elaine. I come from a building automation system background, so very intriguing stuff to me. It makes a lot of sense. So good presentation.
Thank you. Thank you.
Sure. So I'm going to go on and share my screen. It should be popping up right now. Okay, unless I hear any complaints, I will jump right into it. So I'm Stephen Carter. Again, our company is TRAXyL, and we have developed a way to provide broadband for everyone, and we especially think it's relevant in today's climate with the disaster relief and response. While we've always kind of had it as a timeline activity, we're really starting to see maybe some opportunities now for it as well. So, we think that access to information is critical in your decision making and in your day-to-day life and activities. And the access to information is difficult to get, and the ways that you get it can often come from online activity connected to the internet, other sensors like some of the others we're just discussing. And like I mentioned, it's really relevant in the COVID pandemic, and getting connectivity and information and the spread of information very quickly and in real time can help expedite some of those the data sharing and some of the relief and response efforts. Some of our activity is really relevant in quarantine areas, pop-up hospitals and medical. But also in the healthy community where we're all quarantining and we're trying to get telehealth or telework or even school type applications happening at home. And so connectivity is really relevant. And really we're thinking about broadband. We're thinking about getting connectivity to wireless antennas. We're thinking about trenching, getting cables in the ground, hanging them on the utility poles or some of the traditional ways of doing that. The challenges that we come across when we're trying to trench, you've got to design for that, you've got a permit for that. And then once you go to trench, you might have identified by doing some scans or x-rays to understand what's in the ground, but you really don't know what you're going to hit until you start excavating. So it's a very timely process. It takes a lot of time, it's expensive, it can be dangerous to the environment and to the operator and installer. And so we think about it from a more minimalist approach, a safer and simpler and quick approach where we're essentially painting optical fiber onto the road surface to get broadband into hard to reach areas. So we developed what we call fiber tracks, and it's a very quick installation. We like to think that we're the only solution for on-demand fiber installation infrastructure. You don't have to go through the months of trenching, the months laying pipe, and then actually repaving or relaying new road where you've dug it up. You can actually paint a line onto the road. So it's very quick, it's very time and cost efficient, and it's versatile in a way that if you want to get the IoT sensors out for monitoring wastewater or try to get something across a chiller room floor, indoor applications, or try to get a wireless antenna up outside, you don't have to excavate to get that done. A lot of the challenges with getting wireless, which yes, it emits a broadband or a wireless signal out, but they require fiber to back all that data. So it's a very quick way of getting sensors and other IoT and devices quickly connected. So we're not literally painting, but the final product does look like a paint line on the road, but it blends into the surface. So the photo you can see there is a black stripe on a black asphalt. The profile that we show, it's about the size of a paint stripe in width. Height, if you think about highly trafficked or crosswalk type intersections where the paint is raised off the surface ever so slightly, that's the type of profile that we're looking at. Our fiber is encased in a protective steel armor. It's a very low profile cable. And then we use a few layers of protective coating, one to allow for expansion and contraction in the road, the other to allow some durability for surface and top protection. There are ways of installing cables. We're used to it because if you think about going a mile in any direction, probably from where you're sitting right now, there's probably some sort of activity that goes on nearby. You see boring or trenching, you see utility pole work. And if you think about the process that it takes to install that mile of fiber, that mile of communication cable, it probably sits on the side of the road and you pass that construction site for weeks or months before it actually gets installed and put back in place. We're a very quick, simple, elegant solution to getting fiber, which is the preferred means of telecommunication and data transmission out. So yes, there are other ways of doing it. We are faster, and we provide the fastest communication data. I'd also say that we don't claim to be a silver bullet for any of this, right? So if you want to trench across a field because it makes sense, you're in soil and you know that you can trench across that field, you can do that and then transition right onto the maybe a parking lot and then go to a utility pole on the other side of that parking lot. It has the hard surface already there and existing utilities underground. You might have water, communication, mechanical, electrical, utilities underground. This is just another tool in the tool bag to avoid those. So trench across the grass where it makes sense, run fiber tracks on the surface of the parking lot, go to a utility pole on the other side. The fiber is the same fiber that's used in all of these methods. It's just dependent on whether you want to trench or you want to run fiber tracks. So we think about it as another tool in the tool bag for installers. And in that same vein, we want to be able to we have been a contractor going out and doing installations where we've been able to go out and perform installations for ISPs or for utility companies, municipals. And our idea is really we're developing these machines now so that we can get them in the hands of the installers across the world. We want to be able to enable them to go out and make connectivity happen very quickly and service their customers. So we're creating the equipment. We're selling the protective fiber and coatings, and we're also providing the training. So a lot of our go-to-market, we think about bases, office parks, airports, campuses, business parks, residential communities, areas where they need fiber to go in quickly. They may not need miles and miles of it, but they could certainly use it across a road, across a parking lot to really bring down that major cost. Some of our recent traction is, we have been a part of a few incubators, accelerators. One of the most recent ones was Mash Challenge in Texas last year, where we took the top prize. We competed against about 75 different companies, and we took the top prize in Mash Challenge. Interestingly enough, we also participated in a Satellite 2020, where Elon Musk was the keynote speaker, and we pitched at the startup space event for that. And while there was lots of other companies pitching satellite equipment and technologies, it was actually our technology that took the first prize there as well. With all of the space race activity that's going on, you still need terrestrial and ground level communications to allow for all of that to happen. And the judges there really saw it as a way of expanding and enabling those other technologies. Some of our other customers have come in ways of ISPs, school systems, municipalities. We won an award at Tech Connect Defense Innovation Award last year. And it really resonated with them because we also have contracts, one with the U.S. Army Corps of Engineers, where we're building them a proof of concept machine and laying out a proof of concept demonstration for them of our fiber TRAXlink in action. We also have a U.S. Air Force SBIR Phase 1 grant where we're looking at trying to get flight line connectivity and base connectivity to happen so that their mechanics can can operate on the aircraft on the flight line where it's too far for Wi-Fi connection. And really, you think about those flight lines, you don't want to cut into them or damage them in any way. Others have been ISPs, and this is one of the solutions where we went to Greenville, South Carolina, a more rural part of the area, but it was an apartment complex where there are 36 apartment buildings. We were able to put down multiple links, and hopefully my crosshair is coming up on this, but it's a little hard to see our final fiber tracks line that comes out of view from the left and across over to our machine. We cross right over an existing tar line, and you can barely see our final product. This is one with just the bottom, the one closer in view is just the bottom layer. So you can see our machine in action. It's a little bigger than a riding lawnmower. This is our prototype machine. Our U.S. Army Corps project will help us get to our first commercial prototype that will be installing. So we were able to, in this application, work with an ISP to connect 36 apartment buildings to help get a fiber to the home project online for them. A little bit about us, we do have a really brilliant CEO. He comes from the Intel community where he did a lot of fiber optic specialty projects. He also worked a lot in telecommunication, and he's the brainchild of this operation where he thought about it and trying to get rural broadband to a family member's home, and the service provider came out and said there's no telephone poles in this area. The community doesn't allow trenching, and there's just not enough customers to allow you to get connectivity anytime soon. That kind of what led him to mention it to me, where we've, he knew my background. I mentioned earlier, I come from a background of building automation systems, digital controls and system integrations. So I really got it when trying to think about outside plant and even inside the building connectivity. We have a lot of advisors, don't have enough time to run through each one, but have a very good understanding and background, not only in the startup world and go-to-market, also from established ISPs and tier one and technical backgrounds. So we like to think about how, yes, you can get broadband connectivity, fiber to the home, you can get internet connectivity between buildings and place to place, but with fiber, you could do so much more. It enables some of those other IoT emerging technologies to really come to life. If you think about, kind of mentioned it earlier, 5G is the next wave of wireless. For every 4G antenna that exists, there's going to be about 10 more 5G antennas. And all of those require fiber backhaul. So to get those, you don't want to trench through the urban areas where there's a lot of hardscape surfaces. We also think about the existing pandemic with disaster relief and recovery and trying to get Wi-Fi out to some of those emergency pop-up locations, whether it be for quarantine and medical relief like we're seeing now, or maybe there's some sort of a weather event, a tornado or hurricane where immediate communications need to be set up. We can also think about being anywhere on, near, and around the road is very important for autonomous cars, for high-speed tolling. And then there's another unique application for fiber called optical sensing, where it actually turns the fiber into a microphone. You put the correct electronics on either end, and it turns the fiber into a microphone where it amplifies physical presence around it in a way that it can kind of detect motion. You think about perimeter security around an airport or a base. If a car or a person approaches and it shouldn't be there, it can detect that. It could also detect aerial movement for maybe gunshot detection or helicopter or aerial presence. So, we have been running fiber for pilot projects. We are working with installers to get them machines. We are also working with ISPs and municipalities to get connectivity happening for them. Like I said, same day. So, in parting, we're really another tool in the tool bag, another quick solution to be able to get fiber on demand and into the hard to reach areas where there's a lot of hardscape surfaces. So I will turn it over to some Q&A if we've got some time.
We do, and there are two questions already. First question, in general, how many feet can be laid down in any 8-hour period? or, you know, if there's a per hour minimum?
Yeah, absolutely. So good question. Currently, we're working with a garage-built prototype machine, the one that you saw in the video or in the photo. It looks that good because it was a two-car garage. So and it lays about 500 feet an hour. Our next machine that we're working with for the U.S. Army Corps will lay about 1,000 feet an hour. And we are looking to take that up to walking speed, somewhere around 2 to 3 miles an hour. So we are extremely pleased with the 500 mile an hour. We expect to get to 1,000 miles 1,000 feet per hour very quickly.
Is there a limit to the weight it can bear?
So fiber itself can take a lot of pressure. It has just in and of itself, it's very durable as far as pressure goes. The fiber that runs transatlantic cables takes a lot of pressure. We have lab tested our technology where we used for traffic, where we had residential traffic. We had a weighted wheel of almost 1,500 pounds cycle over our fiber line for almost 700,000 wheel impacts. And we have been able to, our solution didn't fail. One of the family samples that we're laying out today didn't fail. So we haven't come across a weight problem right now. A lot of that weight load is distributed as a wheel crosses over. It distributes that weight. So the PSI in any single point is not that high. What we really want to avoid is a extending that bend radius where you have a sharp pressure, and we alleviate that by having our cable protected with the multiple layers. So we've had forklifts, we've had scissor lifts, we've had salt and snowplow trucks run across it. And we're anticipating with the US Air Force that we're going to have large aircraft run over our lines. So we have not met a weight limit yet. We've tested it to some very extreme weights, but right now we have not seen a failure due to weight.
So a couple of other related questions. One is, you know, how much traffic can it withstand over you know, over time, 24/7, 365? And what about any additional durability around, you know, environments like water or like lots of water, and you know, so like port environments.
Mm-hmm.
Is there a lifespan that you might have as well? You know, can you predict when it's going to need maintenance or downtime, or it's going to break, or you need repairs?
Yeah, so there's a lot there. I'll try to get on into all of them a little bit. We know that there's you know, what we're trying to do is match the life cycle of the road. And so there's a few ways to account for that. First, in the design, if you can lay it in a way or in a location of the road, maybe it's on the far left-hand side, maybe it's on the far right-hand side, maybe it's right down the middle where you get the least amount of traffic. That's one way to extend the longevity. We have had the lab testing. We've had it out in the real world. We've had it last for a couple of to several years so far. And you can maintain this. So we think about it like the road. The road goes through maintenance. You might have a pothole, you might have complete resurfacing, but the traffic just doesn't stop getting to where it needs to go. It takes another route. It might take a detour down a side street. It might go into the other lane while that lane is shut down. Because of the ease and cost to lay down fiber tracks, you can think about laying it on both sides of the road. You could think about laying it on every road going to a particular location. And that way you create redundancy, and you also create a mesh network. So that way you really don't have any outages to the end user. The data just gets rerouted down a healthy link. Also with that, we do believe that, you know, with ongoing maintenance, you can make this last as long as you want it to. So putting down the fiber at 500 or 1,000 or several thousand feet an during its first pass will be sped up much quicker when you're just going through and literally laying a paint line on top of that. You know, with our, I say literally, you're literally driving it in the same way, but the protective coatings are much more durable. So there's a maintenance process, and even with that maintenance process, it dramatically brings down the cost of the installation. We have not tested it underwater. We have had our lines emerged in water because of puddles or heavy downpours. The materials that we're using are unique to us in a way that they are a custom blend. So that top coat that you see in the video is already, or in this presentation, it's already being used in highly trafficked, harsh conditions. It was actually a material developed in Northern Europe for very cold, wintry conditions. So it's being used in the world already for striping and on the road. So oils and traditional chemicals that you might find in the road are not really known to break this material down very quickly. It is a very robust material. I hope that answered the question.
Yeah, there's a lot of very similar questions to that. I'm not going to be able to get, given the time constraints now, and I'm not going to get through all of these additional questions as well. But I will choose a one question that I think is kind of relevant. What's the cost per feet?
Great question. So when we go out and do our installations today for ourselves for a customer, we charge $13 a foot. When we lease our equipment out to the installer, they can buy the couple of layers of protective coating and our cable for $9 a foot. So they would be able to go out and install thousands of feet a day at a cost to them of $9 a foot.
Okay. And kind of a last question here, but there's also another related question. Is it modular? And is there, do you only position yourself as a kind of a short haul solution, or is this, can this be much longer?
Yeah, so modular, I'm taking that to mean, can it fit into other applications? If I'm interpreting that incorrectly, I apologize, but it can integrate with a buried trench. It can integrate to a telephone pole. We can run up right along the side of a building where a conduit comes down and integrate into a junction box. There's no limitations to integrating into existing networks or equipment. And I think the second question was around, I apologize, give me that one again.
It is short haul, long haul.
Yes, great question. So we look at last mile. It's really that last mile can be 10 times more expensive than the middle mile or the long haul. So we look at last mile connectivity as our bread and butter type of location, but also getting out to many other spaces is possible.
One last question, and then we'll wrap it up. What about IP protection plans? What keeps people from copying this?
Yeah, so we do have a patent portfolio that we're building. We've got 2 issued patents. We've got other pending patents. And we've also, while the materials themselves are not unique, they are the proprietary, there is a sense of the proprietary blend in the materials to give them characteristics that we're looking for in terms of flexibility, but also in durability.
All right. All right. Thanks very much, Stephen. I'm going to hand it back to Anne.